Hello, everyone. I'm Ryan Fogt, professor at Higher University in the Department of Geography and director of the Sky Laboratory for Atmospheric Analysis. As you meet this week to discuss the planning priorities for the IPY-5, I'm coming to you with some ideas of some research questions that exist in my field of atmospheric science and sea ice variability around the Antarctic continent. These are things that are open questions still in my research community that I think are priorities for the international community as well that can be addressed in the next phase of IPY-5. So first is the southern annular mode. This is a large-scale pattern of atmospheric variability that spans much of the southern hemisphere. It influences the jet stream around Antarctica, how strong it is, its latitudinal position. It influences things like the sea ice extent, temperature and precipitation anomalies across the Antarctic continent, and the ocean circulation as well. In 2020, I wrote a review paper on the southern annular mode with my colleague Gareth Marshall, and we had an open question at the end of that paper, which I'll get to in a second. But one of the things that has been evolving in our science community is these positive trends in the southern annular mode index seen by that time series here on the slide. And particularly in the austral summer, the southern annular mode has been strengthening, largely due to Antarctic ozone depletion in the stratosphere. That strengthens the westerly winds, pulls them closer to the Antarctic continent, and leads to a positive phase of the southern annular mode. You can also see that in the annual mean. However, the future is much more uncertain what's going to happen with the southern annular mode, in part because we're expecting Antarctic ozone to show signs of recovery due to the Montreal Protocol, at the same time that greenhouse gases are expected to increase through global emissions. So as greenhouse gases would lead to a positive phase of the SAM, the recovery of ozone would do the opposite and lead to negative phases of the SAM. And so it's unclear when these two things might change and how they might influence the state of the southern annular mode, and then broadly the large-scale climate of the southern hemisphere, including all of Antarctica. So the open research questions that I see for this area are: when will the greenhouse gas signal start to emerge in other seasons outside the summer? And we know that it's going to play a role in this in all seasons, but in the summer we're going to see this conflicting tug of war between ozone recovery in particular with greenhouse gases. So when will we start to see the climate change signal appear in other seasons of the southern annular mode? And how in the summer will increasing greenhouse gases counter this role of ozone depletion? And then lastly, how does the role of the background state of the SAM play for more short-lived extreme events, things that are emerging as a topic of research activity like the atmospheric rivers, which are known to drive really large temperature extremes and can lead to melt events or increased snowfall depending on what time of the year and what location they're occurring. As the same as the background winds across the southern hemisphere, there has to be connections to this in the short-lived weather features like these atmospheric rivers. And it's an open question how these might change in the future and what role they might play as ozone recovers and greenhouse gas increases. Another area of my research is on Antarctic sea ice extent. And so you probably know a lot about how sea ice is changing quite a bit in the Antarctic. We had record highs in 2014 into 2015 that rapidly declined into record lows that were first set in 2017, then again in 2022, and most impressively in 2023, when much of that whole year was well below average. And so you can see here this figure of the Antarctic sea ice anomalies and how dramatic the last few years have been compared to long satellite history starting in 1979. The reasons why this shift are occurring are an open area of research right now. Many are looking at the role of the ocean changing and providing a more persistent effect on the sea ice, and perhaps using the words like a regime shift, where the previous 30 years of Antarctic sea ice variability were largely driven by the atmosphere and the winds, and now we're seeing a change in the Antarctic sea ice extent, driven a lot by the ocean perhaps, with the role of the atmosphere in certain regions continuing. And so there's a lot of open questions into the Antarctic sea ice because we're seeing new changes that perhaps haven't been seen before. And understanding the causes of these changes and how they might look in the future is really an important question, I think, for the global scientific community that looks at Antarctic sea ice anomalies and their behavior. So these questions include: how long will these well below normal sea ice extent anomalies persist into the future? Are they just a few decades, or will this be the new state of Antarctic sea ice? Will it rebound to normal again, or will it be in this persistent below average state from here on out? What are the connections with these sea ice extent anomalies in the ocean system? We know that sea ice formation plays a critical role in the rejection of brine, and that can form a really cold, salty water that sinks to the bottom and form the Antarctic bottom water. Is this going to change in the future if we have less sea ice extent growth in the winter and less sea ice through the summer as well? What are the connections of global overturning circulation as sea ice responds and changes in the Antarctic? How will these sea ice extent anomalies affect other things on the Antarctic continent, including the grounded ice sheet and the buttressing effect from the Antarctic ice shelves? We know that these are key features that are leading to ice loss right now in West Antarctica and the Amundsen Sea, and even in places in East Antarctica right now. And so as sea ice declines, it leaves more exposed ocean to the ice shelves, which can impact their change. And we're curious to know how this might affect then the grounded ice sheet and global sea level rise moving forward. These are really great questions that need more explanation. What are the implications for the Antarctic sea ice and the ecosystems that live and depend on the sea ice? Things like penguins and seals that spend much of their time on the sea ice and a lot of their food in the waters around the sea ice. How will they be impacted both in the short term and in the long term? Will we see declines in the populations like we've seen with a change in the emperor penguins recently that were basically an extreme loss due to the change in the sea ice really rapidly, and they lost much of their young really quickly? Or will we see adaptations from these species that are able to rebound and change through the changing sea ice conditions as well? And models for Antarctica do a poor job right now representing much of the sea ice behavior, where the observations showed an increase up until around 2015. The model showed a continuous decline in the sea ice. And so this may be a window of opportunity where we can learn more about why the models are projecting different changes than the observed for the beginning part of this satellite era, and learn from this really rapid decline in the Antarctic sea ice extent in a way that we might be able to understand more biases in the models together. I consider these areas really important research questions in my community. I hope that you'll consider discussing them at this meeting and look at them as priorities for the next IPY5.